we are going to take a look at swapping between our quadratic function forms. I'm in your remediation packet, and we're going to start on page 2, and we're just going to look at a bunch of different examples of how to swap between these quadratic function forms. So number 11 gives us a function that's in standard form. So I'm going to go ahead and jot this down in our standard form box. I know standard form tells me the y-intercept, and the y-intercept is our c value at the end of the function. So in this case, our y-intercept is 16. Now I want to change this to factored form and to vertex form. So I'm just going to go in order here. For factored form, I'm looking for factors of 16 that would add to -10. Make a list if you need to, but this would be -2 times -8. Those numbers multiply to 16, but would add to -10. So my intercept or factored form would be x minus 2 times x minus 8. Remember that our intercept or factored form tells us the x-intercepts, and our x-intercepts come from inside our factors. Remember, it's the opposite signs. We have an x-intercept at +2 and at +8. So at 2 and 8, and remember, we don't put parentheses around a list of x-intercepts. To change the vertex form, we need to do that completing the square process. So we know that our vertex form always looks like x in parentheses with something squared. We fill in the blank here with our b value, our middle number, cut in half. So -10 cut in half is -5. We keep our original c, which is 16 here, but then we have to subtract off our cut in half number squared. So in this case, we're going to subtract off 25. Okay. So our vertex form is y minus 5 squared, and then 16 minus 25 would be -9. Vertex form gives us our vertex, and the vertex for this function would be 5, -9. Again, when I pull a number out of parentheses with x, it changes the sign. So that's why we have +5, -9. Number 12, we've got 2 parenthesis groups here. That's factored form or intercept form. So I'm going to fill that in here, x minus 7 times x plus 1. Factored form we know gives us the x-intercepts of our function, and our x-intercepts here would be +7 and -1, opposite the signs that I have in parentheses. I'm going to go to standard form next. We need standard form in order to get our vertex form, so I'm going to get standard form next. To get standard form, I'm going to take my factored form and distribute. So x times x gives me x squared plus 1x minus 7x minus 7. And then we need to combine our like terms, these x terms here in the middle. So my standard form would be y equals x squared minus 6x minus 7. Remember, standard form gives me the y-intercept, and the y-intercept is our c value at the end. So our y-intercept here is -7. Next, we're going to find vertex form. Again, I know vertex form looks like x in parentheses with something squared. So to finish off what's in parentheses, we take our b value from standard form and we cut it in half. So -6 cut in half is -3. We keep the c that we have, which is -7, and then we subtract off this cut in half number squared. So 3 squared is 9. So for our vertex form, we get x minus 3 squared, and then this would be -16. So our key feature from vertex form is the vertex of that function, and the vertex of our function would be 3, -16. So we've started with a standard form, we started with a factored form. Let's turn the page and see what's next. For number 13, we're starting with standard form again. Everything's all multiplied out. I've got an x squared term, an x term, and a constant term. That tells me standard form. So I'm just going to put this in the standard form box. I know standard form tells me the y-intercept, and the y-intercept here is 45, way up there. And then I need factored form and vertex form. When I have standard form, it doesn't matter which of these I find next. I'm going to go ahead and find factored form next, just because I'm going to go in order, but it doesn't matter. So for factored form, I'm going to look for factors of 45 that add to 18. If you need to make a list, make a list. So 1 times 45. I can't do 2 since 45 is not even. I could do 3. So that would be 15 times 3. Oh, and those are the factors that add to 18. So those are the ones that I want. So my factored form would be x plus 3 times x plus 15. There's my factored form. Factored form, remember, shows me the x-intercepts. And my x-intercepts here are -3 and -15. Remember, no parentheses here. I'm not describing a point. And then finally, vertex form. So I know vertex form is x in parentheses with something squared. The something with x is, again, that b value cut in half. So 18 cut in half is 9. It's plus 9 here because we have a positive 18. If we flip back to our last examples, we had minus because we were cutting a negative number in half. So x plus 9 squared, we keep the c value that we already have, but then we have to subtract off our cut in half number squared. So 9 squared is 81. So I'm gonna keep the x plus 9 squared. And then for 45 minus 81, I need to clean that up a little bit. So 45 minus 81 gives me -36. So my vertex form would be x plus 9 squared minus 36. There's my vertex form. It's called vertex form because it gives me the vertex. And the vertex here is -9, -36. Remember, the x portion of the coordinate is opposite what we see in parentheses here, opposite sign. The y value is exactly the same. And I do put parentheses around this one because this is a point. For number 14, I've got vertex form to start. If I see something in parentheses squared, that should make me think vertex form. So I'm going to go ahead and jot vertex form down in my box here. 2 times x minus 3 squared minus 2. Vertex form, we know, gives us the vertex. And my vertex here is 3, -2. Remember, we pull our vertex directly from vertex form. The 2 in front tells me that the graph is going to be stretched by 2, but it doesn't change our vertex. From vertex form, I'm going to go to standard form. So I'm going to take my squared piece, that x minus 3 squared, and write it twice. And then the first thing I'm going to do is distribute these. So this would be x squared minus 3x minus 3x plus 9. Be careful with your signs. And now I have to follow order of operations 2 times all these things. So I'm going to take 2 times all this stuff. I would get 2x squared minus 6x minus 6x plus 18. And then don't forget our minus 2 at the end here. The last thing I need to do to have standard form is combine my like terms, so tidy this up. This is our only x squared term, so we're starting off with 2x squared. Minus 6x is minus 12x. And then 18 minus 2 is 16, so plus 16 at the end. Here's my standard form. Remember, standard form gives me the y-intercept, and my y-intercept is that constant term at the end, so 16. And then finally, we'll change this into our factored form. So when I'm factoring, the first thing I want to look for is a GCF. The problems that we've changed into factored form so far haven't had a common factor. We haven't had anything in front of that x squared number. Here, we actually could divide all these terms by 2. So I'm going to start by factoring out that 2. That leaves me with x squared minus 6x plus 8. And now if I look inside those parentheses, I still have an x squared, so that means we can keep factoring. I want factors of 8 that add to negative 6. That'd be negative 4 times negative 2, or negative 2 times negative 4. So my factored form would be my GCF in front, don't forget that, and then x minus 2 times x minus 4. There's my factored form. Factored form, remember, shows me the x-intercepts, and my x-intercepts here would be positive 2 and positive 4. Just like with vertex form, we can see the vertex directly from our function. We can see our x-intercepts directly from our function. The 2 in front here doesn't impact how we find our x-intercepts. We have a couple more problems on the next page. Number 15, we are starting in factored form. So we've got factored form here. I'm going to go ahead and fill that in this middle box, x plus 3 times x minus 5. Remember, factored form gives me my x-intercepts, and my x-intercepts here would be negative 3 and positive 5. From factored form, I'm going to go to standard form, which means I need to distribute my factors here. I'm going to multiply these together. X times x is x squared minus 5x plus 3x minus 15. For standard form, the last thing I need to do is combine any like terms. This is my only x squared term. And then negative 5x plus 3x would be negative 2x, so minus 2x. And then here's my only constant term, minus 15 there at the end. Remember that standard form shows me my y-intercept, and my y-intercept is the constant term at the end. So negative 15 would be our y-intercept here. And then finally, we'll change this into vertex form. So remember, vertex form is x in parentheses with something squared. The thing that goes in parentheses with x is our b value from standard form cut in half. So negative 2 cut in half is negative 1. We keep the c that we already have. We keep the constant term from standard form, and then we need to subtract that cut in half number squared. So 1 squared is just 1. Then we tidy this up. So we get x minus 1 squared, and then negative 15 minus 1 would be minus 16. The vertex form gives me the vertex, and my vertex here would be 1 comma negative 16. Last problem in this section, number 16, we are starting with vertex form. We've got something in parentheses squared, so that's vertex form. I'm going to go ahead and jot this down in that box. X plus 2 squared minus 1. The key feature I get from vertex form is the vertex. And then my vertex here is negative 2 comma negative 1. From vertex form, I'm going to change this into standard form. So I have x plus 2 times x plus 2 minus 1. Remember that thing that's squared, I write it twice. That's what squared means. It means I have that thing times itself. And then I need to multiply these together. So x times x is x squared plus 2x plus 2x plus 4. And then don't forget your minus 1 at the end. We'll combine like terms here. So I get y equals x squared. 2x plus 2x is 4x, so plus 4x. And then 4 minus 1 would be 3 plus 3. Standard form gives me the y-intercept, and my y-intercept is that constant term at the end. So 3 for our y-intercept here. Finally, we're going to find factored form for this function. So we're looking for factors of 3 that add to 4. That would just be 1 times 3. So my factored form would be y equals x plus 1 times x plus 3. Remember, factored form gives me x-intercepts, and my x-intercepts for this function would be at negative 1 and negative 3. Okay, so we've just done several problems identifying our function form and its key features, and then rewriting in those alternate function forms. Okay, we've swapped back and forth between every version that we've learned here: standard form, factored form, and vertex form.